Welcome to 9.2, Solving One-Step Equations with Addition and Subtraction. Yesterday, we looked at the connections between addition and subtraction and how they can both be used to either balance or solve equations. Today, we're going to talk about just straight-up solving equations. Before we can do that, we need to look at inverse operations. An inverse operation is an operation that undoes the effects of another operation or function. Let's look at what this means. Pick any number. For example, 2. 2 plus 5 equals 7. So that is addition. That's one operation. The inverse for addition is subtraction. So if I take my new sum of 7 and subtract 5, I get 2 again. They undid each other. I used the same value once I added, one I subtracted. They undo each other. I always think of it like a zipper. The same operation, the same function, just going in different directions. Addition makes it bigger, subtraction makes it smaller. So addition and subtraction do the exact opposite of one another. They are inverse operations. Now if we look at 8 and negative 8, if I add those together, I get 0. It's the same as saying 8 minus 8. This is what we call the identity for addition and subtraction. This is when we are solving equations. In order to cancel out a value on one side or the other, we're creating the identity. We're making 0. So when I say the words cancel out, what I'm really saying is making 0. So to sum, addition and subtraction cancel each other out. So when we're trying to get rid of subtraction, we'll use addition. When we're trying to get rid of addition, we'll use subtraction. How does this help us solve equations? When you solve an equation, the goal is to get the variable by itself. We discussed this yesterday when we discussed the term solving. We do this using inverse operations. Just like addition and subtraction, they're inverse operations. You need to keep things balanced. We discussed how equations are always balanced. If you do it to one side, you need to do it to the other side. Now let's look at x plus 19 equals 42. We don't know what x is. We know 19, it's a constant, and we know 42. I need to get the variable x by itself. Well, if I look, what's currently happening to x? I have x plus 19. I'm adding 19. I know that I can undo an operation by using its inverse. If I'm adding 19, I can undo it by subtracting 19. If I do it to one side, I do it to the other. Otherwise, it will not be balanced. This equation will not have the balance it started with. We talked about the term identity. 19 plus negative 19 gives you 0. When you add opposites, you get 0. So now I have x by itself. I'm going to rewrite the left side of the equation. X is now by itself. Let's look at the right side though. 42 minus 19. I should get 23. X equals 23. We can check this by plugging it back in. 19 plus 23 gives me 42. So we call it a true statement. So let's try a couple of these together. What is happening to my variable? I have x plus 8 equals 12. We're adding 8. How do we undo addition? We subtract 8. These are the two big questions you always need to ask yourself. What's happening to my variable, and how do I undo it? A lot of people just jump to question 2, but especially when we get to two-step equations, the first question becomes very important. To undo addition, I'm going to subtract. Subtract from both sides. 8 plus negative 8, or 8 minus 8, gives me an identity of 0. X plus 0 is just x. 12 minus 8 is 4. We have 7 equals x minus 9. You have to ask yourself, what's happening to my variable? Not what is my variable doing, but what's happening. How are the operations and values around it affecting it? It's almost like if you were doing order of operations. If we knew what x was, well, we would subtract 9. That's what we would be doing. That's the first operation. So we are subtracting 9. To undo subtraction, to find the inverse, we're going to add 9 to both sides. I looked at what was there in order to decide what I needed to use. Both questions are very important. What's happening to the variable? How do I undo it? I need to make sure I get the identity. Negative 9 plus 9, or 9 minus 9 gives me 0. If I get my identity, I know my x is by itself. 7 plus 9 is 16. Two important questions. What is happening to the variable? How can I undo it? You need to ask those questions, both of them, every single time. What's happening to my variable? I'm subtracting 3. How do I undo it? I add 3. Three minus 3 is 0, so I have x by itself. On the right side, 15 plus 3 is 18. The next one presents a very common mistake. 19 plus x equals 15. What is happening to my variable? This is where that first question becomes very important. Not what is my variable doing? I'm adding x to 19, true. But we need to think about that our commutative property of addition. 19 plus x is the same as saying x plus 19. So what's happening to my variable? I'm adding 19 to it. How do I undo addition? I subtract. You see how I subtract the same value from either side. 19 minus 19 gives me 0. That's my identity. 15 minus 19 gives me negative 4. Again, by showing your work the way we're showing our work right now, we are setting ourselves up for those calculator moments. I know that 19 minus 19, I could know that those are zeros because they're opposites, or I could type in my calculator 19 minus 19. 15 minus 19. I may not know it off the top of my head, but I have set myself up for a calculator moment. Let's look at what is happening to our variable. I'm adding 4. This one also presents a very common error. I'm adding 4, so to undo that, I'm going to subtract 4. 4 minus 4 is 0. It cancels. It gives me my identity of 0. We need to make sure that everything comes down, including that negative. Now, this problem technically is our first two-step equation. In order to make that x a negative x, we're really multiplying by negative 1. There are two operations coming here. We don't want to, at this point, look at it as a separate operation. We can just simply switch the negative signs. Negative x becomes positive x, positive 1 becomes negative 1. Simple as that. On your own, try these 4 problems, pause, and come back when you're ready. Remember, if you do not show work, you cannot receive full credit for this section. Welcome back. X minus 9 equals 12. We're subtracting 9, so we need to add 9 to both sides. X equals 21. Notice that I'm writing the variable, the equal sign, and the solution every single time, not just 21. What's happening to our variable? In this case, we're adding a negative 13, or you could think of it as subtracting 13. We've talked ad nauseum about how negatives and subtraction are so closely related. In fact, they do the same thing. We're taking away 13. So if I'm taking away 13, I need to give back or add 13 to both sides. You would get x equals 22. Again, I'm just giving you answers. Please show your work. This is how we know that you are participating and actively learning. What's happened to my variable number 3? I'm adding 11 to undo 11 or undo addition. I'm going to add, subtract from both sides. If I do it to one side, I do it to the other. I get my identity of 0, negative 12 plus negative 11, or negative 12 minus negative 11 gives me negative 23. So x equals negative 23. It's okay if the x is on the right side. It means the same thing. What's happened to my variable? I'm subtracting 12. To undo that, I'm going to add 12 to both sides. Negative 12 plus 12 gives me 0. X equals 0. At any point, if you wanted to check these, you could plug them back in. 21 minus 9 is 12. Negative 13 plus 22 equals 9. Negative 23 plus 11 equals negative 12. 0 minus 12 equals negative 12. We just covered one-step equations involving addition and subtraction. Take a moment, rank how well we hit our target. If you don't feel it was hit well enough, make sure to bring your questions tomorrow during Fast and Studious and during practice. I will see you in class.